All right, so for number 7, we're going to graph and convert each complex number into a polar number. You want to try to work on these without a calculator, okay? All of those formulas that we just talked about with x squared plus y squared and the theta and the r, the theta and the r is really going to stay the same. The only thing that's going to change is your x and y. Your x in this case is going to be the same as the a value, which is the first real part of the complex number. The y value is going to be your b value, which is actually the imaginary part of the complex number. So in this case, you have your a value is -3, which, and when you square a -3, you get the same thing as squaring a +3, so that's why I don't have a negative sign here. But you could just as easily replace a negative here and put parentheses around it, and you would get the same answer. So 3 squared plus 4 squared, take the square root of that, you get 5. Okay? For theta, still tan inverse, but it's tan inverse of b over a, so -4 over -3, which is really just the tan inverse of 4/3. Now, you should not know what the tan inverse of 4/3 is off the top of your head. That's definitely something that you want to put into the calculator. Now, since this point is in the third quadrant, whatever I get when I evaluate tan of theta, I'm going to actually add 180 to it, because in the third quadrant I take 180 and I add to it whatever the angle is. So when you, in your calculator, do tan inverse of 4/3, it's going to give you an angle, and then you're going to add 180 to it. Okay, so in this case, you should get 53.130 when you put in tan inverse of 4/3. Now, you want to add 180 to that, and this is really just cosine of 233.130 degrees plus I sine of 233.130 degrees. Same thing here. Graphing, you want to go over 3 and up 1. So you're in the first quadrant. R equals √10. Tan inverse of 1/3. That, again, is not something that you should know off of the top of your head, okay, because it's not a typical tan value on the unit circle of your 30, 45, 60, 90, etc. So therefore, when you do tan inverse of 1/3, you get 18.453. Now this cis is, I just wanted you to see the relationship here. It really doesn't matter. You can interchange this cis with cosine plus I sine. Really all this is √10 is your R value. And then you replace the theta value for cosine of 18.453 and then I sine of 18.453. But instead of writing 18.453 twice, you just do cis 18.453. So this is just another way of writing the cosine plus I sine version. Okay? Same thing with the last one, √3 minus I. Your a value is √3, your b value is -1. So therefore, you get -1 over √3, you do the tan inverse. Now that one is a typical value. You should know that as 30 degrees on your unit circle. So tan inverse of -1/3 in this case is 30 degrees, or gives you the reference angle of 30 degrees. Now since you are in the fourth quadrant, you're going to take 360 and subtract that reference angle of 30 degrees, and you're actually going to wind up at 330 degrees. So 2 is your radius, or your R value, and then cis of 330.